Hi everyone, today I'm going to teach you how to perform a hypothesis test for a mean. This test helps us decide whether a sample provides enough evidence that a population mean is different from a claimed value. I'll explain the steps and then work through an example. A one-sample t-test compares the average from one sample to a claimed population average. We use this test when we don't know the population standard deviation. Our goal is to determine if the sample gives enough evidence that the true population mean is different from the claimed value. Let's solve an example together. A random sample of 200 university students was asked how much money they have in their bank accounts. The sample average was $1,030, with a standard deviation of $700. We want to know if the true average amount of money students have is different from $1,000. We'll use a significance level of 0.05. First, we write the hypothesis. The null hypothesis states that the true average bank account balance is $1,000. The alternative hypothesis states that the average is different from $1,000. Next, we calculate the t-statistic. We subtract the claimed mean from the sample mean and divide by the standard error. This gives us a t-value of approximately 0.61. After calculating the t-statistic, we find the p-value. The p-value is about 0.54. Because 0.54 is much larger than our significance level of 0.05, we fail to reject the null hypothesis. This means we do not have enough statistical evidence to say that the average amount of money students have in their bank accounts is different from $1,000. Now let's look at one more example. This problem asks us to test whether the population mean is less than 73.2. We're given a sample mean of 72.6, a population standard deviation of 6.2, a sample size of 39, and a significance level of 0.01. Since the population standard deviation is known, we'll use a one-sample z-test. Even though it's a z-test instead of a t-test, we'll follow the exact same hypothesis testing steps. The first step is writing the hypothesis. The null hypothesis says the population mean is equal to 73.2. The alternative hypothesis says the population mean is less than 73.2. Since the alternative hypothesis uses the less than symbol, this is called a left-tailed test. Next, we calculate the test statistics using the z-test formula. We subtract the claimed mean from the sample mean, which gives us negative 0.6. Then we calculate the standard error by dividing the population standard deviation, 6.2, by the square root of the sample size, which is 39. That gives us approximately 0.993. Finally, we divide negative 0.6 by 0.993 to get a z-statistic of approximately negative 0.604. For a left-tailed test with a significance level of 0.01, the critical value is negative 2.326. Our test statistic is negative 0.604. Since negative 0.604 is greater than negative 2.326, it does not fall into the rejection region. Because of this, we fail to reject the null hypothesis. To summarize, a one-sample t-test helps us determine whether a sample mean is significantly different from a claimed population mean. We first write the hypothesis, calculate the t-statistic, find the p-value, compare it to the significance level, then write our conclusion in context. In our example, the sample average was slightly higher than $1,000, but the difference was not statistically significant, so we failed to reject the null hypothesis. Thank you for watching.